All right, what's up, guys? This is Ryan from Elevate Security with another video. Now, this one is a really important vulnerability to understand, not even just for the OSCP, but definitely in the real world as well. But definitely understanding this vulnerability for OSCP and whatever CTFs you might be doing in the future is really important as well, and will really help you out. This one that I'm going to be covering today is called Insecure Deserialization. Now, before I really go into showing you how to exploit this common vulnerability, let's first cover what is deserialization. You might have heard of the term before, and I think there's a lot of people in the security space as well, maybe like newer pen testers, that they've heard of deserialization, but they don't really understand what it is, and maybe they're a little bit unsure. So what deserialization is, essentially it's a feature in programming languages. I think most programming, if not pretty much all programming languages, are capable of doing this. What it is you're taking data and you're transferring it from one format, the format that is stored on disk, to a format that can be processed programmatically. Now, let me just break that down because that might be a little bit confusing as well, right? I want to distill this into as simplistic, easy to understand manner as possible. So, all right, let's think of a format where data is stored and can be stored on a disk, right? Let's think about something like XML, as we have here from our previous video, or even something like JSON, JavaScript Object Notation. That's actually a more common standard nowadays in the modern computing world, is to store data on, as JSON, right? That's a really nice format, but the thing is, if you want to use it in a programming language like Python or Java or something like that, what you're going to need to do is you're going to need to take that data from your markup language stored on disk or whatever, and you're going to need to convert that into a format that Python can use and store. So basically storing these fields as variables, right? Like, that's what I mean by processing the data programmatically, right? Like say we want to take the data from this author tag here, and we want to store this value into a variable that we then do something with in Python, right? This is where a use case where we're going to need to be able to convert it from XML into a format that Python can process, right? Now, the act of doing that, the transformation of doing that, is what is known as deserialization. Now, conversely, if we wanted to go the other way, like take some kind of variable from Python and we wanted to export that and store it as XML or JSON, that would be known as serialization. So in the case that we're interested in here, we're looking at, going from, say, XML, or it doesn't even have to be XML. It could even be like a string in the post data, as we will showcase in this exploit here in a second. It could be going, that way. Or, could be coming from that. It doesn't have to be XML or JSON, right? It could just be from the request data. Either way, we're going to be transforming that into something that can be used by Python in this case. We're going to deserialize it. Now, on this box here, one thing you'll notice is this pickle here, pickles. Now, pickle is a serializer and deserializer for Python that is actually known to be vulnerable to insecure deserialization. Now, when I was talking about earlier, deserialization and serialization, these are features of these languages. Just because, this feature is a part of the language does not mean it's vulnerable. What makes it vulnerable is if it doesn't do its due diligence in determining what data should be interpreted as just a string and what data is actually code. If it can't discern that, what you could end up being allowed to do, and we'll demo this in a minute, is you can actually have your data as some kind of malicious Linux code, right? Like, okay, spawn this shell and connect back to my listener. It's like, okay, first, like we could have data like this, like, okay, first I'll tell you the author name, then I'll tell you the content here, and then after that, by the way, execute this malicious code and connect to my netcat listener. And so basically you deserialize that, and if the deserializer is, you know, an insecure deserializer, it's not able to discern between what is code and what is, you know, just text. What it will do is it'll start reading through this and evaluating everything very literally. So it'll say, okay, this is the author. Okay, this is the content data. Oh, okay, it wants me to run this this code here, this Linux code. Let me run that, right? So that's what makes it insecure, is that a secured deserializer would not interpret that as Linux code, right? It wouldn't connect to my netcat listener. Maybe it would just print out that literal string of the command, right? So Pickle is not that smart, so it is vulnerable to deserialization. So if you do happen to see Pickle, and there's a lot of Java deserializers that are also vulnerable. I'm not sure what they are off the top of my head, but definitely be on the lookout. Do your research, do your enumeration, as we always talk about on this channel. But yeah, that's pretty much the description here. I just know off the top of my head that Pickle is vulnerable to this. But now on to this specific example, and I'll show you how we can actually exploit this because the exploit, the nice thing about finding a deserialization vulnerability is the exploit results in remote code execution. So what I'm going to do here is, you know, we're going to look at this, right? This is, if you're not aware, this code here, this is, I believe, Flask. This is what this looks like. When you have these routes here, that's how you set up your endpoints. So there's this new post endpoint, and it's expecting the post request, the post method. And basically what it's doing is it is taking the data of the request, the stuff in the body, and it's actually decoding it. So it's expecting some kind of base 64, and it's going to decode that base 64 and literally interpret it as literally interpret it, you know? So it's going to literally just assign it to this variable, and from there it's just going to straight up load it. See, pickle.loads this variable. So what this allows us to do is put some malicious code in there, and it's going to load it, and then it's actually going to execute that code. So this should be very trivial from here. In order to exploit this, I'll show you how. So I've already written a script to do this, and I'll just kind of step you guys through it. We're going to need a few libraries for this, a few modules as they call them in Python. This is a Python script, by the way, in Python 2. We're importing Pickle, of course, because this is using Pickle, and then we're going to need base 64. Now what this script does, this isn't an exploit script per se. It's just going to generate the base 64 that we'll need for the data of this request. Now, this run me variable, this is the actual Linux code that I want to run. So if you're not aware of this, this is a very handy spawn a shell exploit that I actually got from Pentest Monkey. I've talked about that a few times on this channel. This is really good. I'll just pull it up real quick for you guys. So you're aware, just Pentest Monkey, just Google Pentest Monkey, and maybe Pentest Monkey reverse shell cheat sheet, and pentestmonkey.net. Okay, that's what it's called. It's gonna give you this message here, but just go to it. I know that sounds sketchy, but no, you're not going to get hacked or anything. It's just going to show you how to hack stuff. It's quite the opposite. So you can see some reverse shell cheat sheets for all different kinds of architecture. Very handy. All different types of programming languages. Very, very handy on OSCP. Definitely bookmark this one. In the case of us, the one we're running is this one right here. That's where I got it from. Now, one adjustment that you're going to have to make if you're running this, is that you want to make sure that you put in with your IP address. I believe this is still my IP address here, 10.10.14.39. This is my port. So now that I have this stuff, so basically, yeah, this is the code that's going to run. And then from here, we're just running this as like OS system and stuff. And so it's going to generate, it's going to encode it, actually run our function here, and it's actually going to base64 encode our payload, and then we can just put that in the body, as you'll see here in a second. Now, let me just verify that's still my IP address and it didn't change, because that would be bad. Okay, yep, it's still the same. Now let's just go ahead and start the netcat listener. Now I put it to connect back to port 1234, so I'll listen on that port. So now that that is set up, what I need to do is go to the new post endpoint. Now it's going to give me an error here. Why? Because remember, it's looking for a post request. We browse to it, so by default that means we are doing a GET request. But what we can do is we can go here, send to the repeater, and change the request method by right-clicking and going to change request method. Now it's a post. Here there was no data, so I guess it gave us an error still. But now what we're going to do is we are going to go back to that script, and we are going to run it with Python. And it's going to generate the base64 that corresponds to our malicious code that we want to be deserialized and run on the target system. So now that we've done that, we can do this right in the repeater. We can paste this in. And we're going to need to change the content type to text. I think that should be a nice, clean format. This should be interpreted how we want. So now we hit send. Notice we didn't see anything. This is always a good sign that you have a shell when you don't see anything back. Just a heads up here. So now if we check our listener, we'll see that we do in fact have a shell. So it was able to run that and give us what we need here. From here, we'll do, the import pty.spawn, start making our shell all nice and clean, and yeah, everything will be pretty smooth sailing from there. So that is how you exploit deserialization vulnerabilities, particularly Pickle. But you could do this with any deserialization vulnerability. You just have to make little tweaks for the, particular thing. Now, I will say, if you're running into trying to exploit a Java-based deserialization, insecure deserialization, there's plenty of those vulnerabilities, but a tool you might want to look into is called Ysoserial. It's spelled like this. That's a good one on GitHub. They have tons of different exploits for deserialization on Java. So yeah, I hope this video was of help to you guys and that you will be able to make use of it on the OSCP or whatever your endeavors may be. And yeah, I will be making some more content on exploiting web apps, and I will see you in a future video. Let me know if there's any questions or comments, as always, down in the section below, and be sure to like and subscribe. See you next time.